So up till now we have seen classification of Rapier machine. So detailed classification we have seen. Now when you want to purchase any Rapier machine or Rapier machine selection is there, the following are the criteria as shown in this slide. So when you want to purchase any Rapier machine, you should first see it is double sided or single sided. That is, you want single sided rapier or double sided rapier, or the rapier which is selected, it should be flexible or it is rigid. The rapier selected is positive or negative. Whatever the wave transfer system is there on the machine, it is Devas type or Gabler type. And last is what, the drive to rapier, to the rapier's left hand and right hand, the drive is going from the housing, drive housing. So that housing is movable or fixed to the machine. That we have to see. So write down this, whatever the selection criterias are there, or this is called as what, classification of rapier machine. While selecting any rapier from the market, or you want to purchase the rapier, we should have the knowledge of these 5 classifications, and out of this we have to select our rapier machine. So note down the points, 5 points. Now we'll discuss some case study of selection. So see here. So this is what our Smith rapier from our weaving workshop. So see here, what type of Smith rapier we have purchased here. The Smith rapier, it is double sided, means left hand rapier is there, right hand rapier is there. The rapiers are flexible, and these rapiers are what, negative. Flexible rapier is always negative, means what, for opening and closing of the gripper, left hand gripper is there, right hand gripper is there. There is no any external device to open these grippers or hands. If it is there, it is what, negative. So this rapier is what, negative. Devas type of system is there, means tip to tip transfer is there. Drive to rapier housing is fixed. Whatever the housing drive to the left hand and right hand, the driving gearbox is there, it is fixed to the machine frame. Only the sleigh is moving forward and backward. So this is what Smith rapier. So take down the specifications of Smith rapiers present in our workshop. Again, another case study we will see. Other machine we are having in our workshop. So this is what Dornier rapier we are having. Dornier company is what, Dornier. So this Dornier rapier serve what, the rapier configuration we are having. It is what, double sided. Left hand and right hand rapier is there, but rigid is there. Means left hand rapier is rod and right hand rapier is what, here, rod. And this rigid rapier is always positive. So gripper present to catch the weft and to transfer the weft, the grippers are what, positively controlled. So here opening devices are there at the center and at the left hand side and right hand side. Again, it is what, Devas type of system, tip to tip transfer, not hairpin system. Again we can see here, drive to the rapier housing, The drive going to the rod of left hand side and right hand, the drives are fixed to the machine frame. This is not movable. Only the sleigh is movable. So this is what Dornier Rapier present in our workshop. So from all these case studies and detailed classification, I think the classification of Rapier, all of you have got how the Rapier machines are present in the market. So take down these points. So next point will start. Now the classification is over, the case study is over. Now the next part of our unit is Rapier drives. So Rapier drives are also very important. The success of every settleless machine depends upon the weft insertion. If the proper weft insertion is not there, then weft breakages are there and downtime of machine will be high and production rate will be less and production cost of the fabric increases. So Rapier drives are also important here. So see here. So first we'll see some introduction of the drives. So in this first point, the Rapier drive should ensure a gentle treatment to the weft yarn. Whatever the drive is there, left hand drive to the Rapier and right hand drive to the Rapier, it should give moment to the weft yarn. So here we are gripping the weft yarn from the giver and it passes to the center of the machine. Then taker comes to the center of machine, exchange the weft and taker takes to the what? Right hand side of the machine. So this gentle handling of the weft yarn is important. So this Rapier drive should ensure a gentle treatment to the weft yarn while it is being picked up by the giver Rapier or while it is being transferred between Rapier heads. So gentle movement is required here. So this is what the main function of the drive. If the drive is not proper, the weft breakages increases. So next, see here the Rapier head, whatever the acceleration and its speed are important, since the type of motion results in high forces acting in the body of the yarn. So Rapier drive gives drive to the Rapier and at the front of Rapier tip head is connected. The speed of the Rapier and head should be what? Proper. It should not be jerky. The force acting on the body of the yarn should be what? Proper. Not maximum force should be there. So here if the forces exceed acceptable limits, whatever the forces we are applying on the weft while inserting the weft from the drives, it should be what? In the acceptable limits. These forces are nothing but what? Tension in the weft. If tension in the weft increases above its breaking load, single yarn strength breaking load. So breaking load means what? The strength of the weft is 10 kilo. Okay. If you increase the load beyond 10 kg, that is 12 kilo load is there on the yarn, then it will break because sustainable capacity of weft is 10 kilo. So always the load on the weft, tension or the forces on the weft should be less than the what? 10 kilo breaking force. So that is, it is called as what? If the forces exceeds acceptable limits, the weft yarn breaks up. So when the tension in the yarn goes beyond this limit, the weft yarn breaks. So this, to keep the tension in the acceptable limits, it depending upon the drives. So more number of weft breakage problem is coming in the shuttleless loom. Even though your shuttleless loom is costlier and you are unable to control the weft breakages, means what? Your drive is faulty or some setting is wrong in the drive. Next, the unwinding speed of the weft yarn is determined by the Rapier moment. This unwinding speed means what? We are unwinding the coils from the accumulator. When the Rapier has caught the weft, So as the rapier moves, we are unwinding the coil, one coil, second coil, third coil, and the yarn required for what width of the fabric. So 7 to 8 coils unwinding will be there from the accumulator. So this should be what the speed of unwinding should be also what in the acceptable limit. If the speed is more, again what happens, opposing force will be increasing, the yarn is running forward and you are pulling opposite, so weft will break. This is called as what, tug of war. So proper unwinding speed of the weft yarn is governed by the what, proper drive. So note down these points, introduction points of the drive. So first we will see flexible drives. So again, flexible drives are very important to handle the weft in the shade. If the drive is not proper, weft breakages increases. So one by one drives we will see. First we will concentrate on the flexible drive and then we will see rigid drive. So this is what first type of drive. So how the drives can be given here. So in various machine, various manufacturers are there. Smith is there, Somet is there, Sulzer is there. Everyone's their own patent in the drive is there. Drive system patent is there. So Smith drive is not same as that in the what Sulzer. They are having its their own drive. So that drives we will see now. So first we will concentrate on the flexible Rapier drive from oscillating sprocket. So this is what sprocket. Okay. So how the drive is going, one by one motion we will see. See the pointer where I am showing, concentrate the figure. So this is what our main shaft. Main shaft means what, our crankshaft. So for the crank, so like this C-type crank is there here on the plain power loom crank you have seen. So same crank is there here, and to the crank we are attached one lever. This lever is there, and the lever is attached to the drive wheel, oscillating drive wheel. So the lever is not attached at the center, it is attached at the side. So side away from the center. So this is what driving wheel. On the driving wheel we are having a belt, and the belt is giving drive to here pinion, and to the pinion we are having what, this sprocket gear. So belt, shear belt drive. As the belt moves, this pinion will move to the pinion. At the side of the pinion we are having a toothed sprocket gear. Tooth is there, and that tooth is matching with the what, our this here flexible tape. So here they have shown flexible tape, and this is called as what, guide housing. So in the guide housing the tape is moving forward and backward, forward and backward, and to the tape we are having again here holes are there. These holes are matching with this sprocket gear. The tapes here, this is what flexible tape, and this complete is called as what, housing. So this tape will go inside and it will be bended in the what, housing up till here. Again it will be released when the tape goes outside. the tape comes out from this housing, total Rapier housing. So this will go forward, backward. When it goes back, the tape is bent in the what? Housing. So like the design is there. So see here how it works. When main shaft rotates, this lever will go move up and down. When this lever will move up and down, this oscillating wheel will move on the one side. Suppose this goes up, this moves on the one side, the belt moves on the clockwise direction, and the sprocket gear moves on the clockwise direction. So gear pushes the what? This rapier forward, flexible tape forward. Again, when it rotates, the lever goes down. This wheel moves anti-clockwise now, and sprocket gear moves what? Instead of clockwise, it moves what? Anti-clockwise, and the rapier comes what? Back in the housing. So like this movement forward and backward is there of the rapier. Here gear is moving, sprocket gear is moving once clockwise. When it moves clockwise, the rapier tape goes up to the what? Center of the machine, this tape. And when it moves anti-clockwise, the rapier comes in the what? Housing. So like this drive is present on the both the side of the machine. This is what left hand side, and on the right hand side duplicate of this drive will be present. And this drive is fixed to the machine frame, and it is not moving with the what? Sleigh. So once again see the how it is moving. Main shaft rotates. This lever will move upward. It will rotate clockwise. Belt will rotate clockwise. Sprocket will rotate clockwise, and your rapier tape goes up to the center. Again, after a while, again this lever goes down. This oscillating will move anti-clockwise. This gear will move anti-clockwise, and rapier, which was in the center, complete rapier tape, it comes out of the fabric width, and the rapier winds in the what? Housing. So this is moving continuously, this is moving up and down continuously, and this wheel is moving once clockwise and another time anti-clockwise. After the center, it is moving anti-clockwise. So this is what one type of drive for the flexible tape, and is also called as what? Eccentric drive. The teeth of this sprocket pass through the holes in the driving band, that we have seen. The teeth of this sprocket pass in the holes. So this is giving the drive to the rapier tape. The reciprocating movement may be given to the sprocket. Reciprocating movement means what? The sprocket is moving one times clockwise and other time anti-clockwise by the crank arrangement. This is what the crank arrangement is. So these such types of drives are present on the what? Both the sides of the machine. Here word we are using eccentric drive. Here we are not having drive simple harmonic motion. Means what? While going rapier it is going fast, and while coming back it is coming slow. Means same speed is not there. While going it is fast, and while coming it is slow. This is called as what? Eccentric. Simple harmonic means what? Same speed while going and while coming. This is what simple harmonic. So drive to the simple harmonic is not there. Drive to the rapier is not simple harmonic. Like pendulum experiment we have seen the physics. Pendulum will keep in the center. We will move the pendulum. Some part will go on the left side of the center, and some part will go on the right side of the center. Pendulum will go left side and right side. The time required from the center to go the pendulum left side is what? 3 seconds, and same time 3 seconds will be required for the what? Left side and right side. So same seconds. So this is what? Simple harmonic. But here the motion is not simple harmonic. When the motion is not simple harmonic, load on the driving arrangement is what? More. Chances of breakage of the what? Machine parts are there. Why the drive is not simple harmonic? Because here we require some dual while passing the web from one side to other side. So this is what flexible rapier drive. Here the reed is having what? Dual. The reed will stop for few degrees to pass the weft. For that the drive should be what? Eccentric. Same speed or motion is not required here. So next drive We will see of the flexible only. See the gearing system or driving system how it is. This is what present on other machine, other type drive system is there. So this is called as cam drive. We can see here main shaft is there and a grooved cam is there. Grooved cam is there. The path is given on this cam. Okay, grooved cam, and this quadrant is there. Half quadrant we can say, half quadrant. So we can see in the figure this is what half quadrant, and at the face we are having the gears. Half segment gear is there, and this gear is meshing with the pinion. Geared pinion is there, and to the pinion at the back side we are having the big sprocket. We can see the sprocket, toothed sprocket. So pinion back side we are having what, big sprocket gear. It is having teeth meshing with the flexible tape. Okay, and this is what tape bended in the what, housing. When the tape goes forward from the housing, the tapes come out, and drive to the tape we get from this toothed sprocket. So now the question is there, how this toothed sprocket moves clockwise and anti-clockwise. So see here, when it moves anti-clockwise, the Rapier tape goes in the housing. Sorry, when it moves clockwise, the Rapier goes in the housing, flexible tape, and when it moves anti-clockwise, Rapier goes up to the center of the machine. So like this drive system is present on the left hand side and right hand side. So this is not connected to the sleigh, it is fixed to the machine frame. We can see here it is fixed to the machine frame, and this whatever the segment is there, segment fulcrum is here, and the segment will move one time clockwise, one time anti-clockwise, clockwise or anti-clockwise. And here the fulcrum is there. How it is moving? Because at the base of the segment the pin is there, the pin will follow the path of the groove. So see here, as the main shaft rotates, cam rotates, and cam gives drive to the pin. So this will move what, one time clockwise, clockwise, and this toothed gear move anti-clockwise. Rapier goes up to the what, center of the machine. Next time what happens, as the cam rotates, this toothed gear moves what, anti-clockwise, and the gear rotates clockwise. So Rapier tape comes what, backside, and it stores in the what, housing. So see here the figure here also, three-dimensional figure we can see here, three-dimensional figure we can see. So here the cam moves, the drive comes from the main shaft, the pin is there, bottom side of the pin is there in the what, groove. So as the shaft rotates, main shaft rotates, this will move clockwise, this gear pinion will move anti-clockwise, this will move clockwise and this will move opposite, and the gear, backside gear is moving one time clockwise. Clockwise means what, this tape will wind in the housing. Here is what housing we can see, and when this sprocket gear, this sprocket gear moves anti-clockwise, the tape comes out up to the center of the machine. So this is fixed to the what, machine frame. It is not attached to the sleigh and is not moving forward and backward. Why? Because this drive is what, heavy, and if it is fitted to the sleigh, again weight of the sleigh will be more. Already the force required for the sleigh to move forward and backward is more. In addition, this force will be there, and sleigh will move slow, and you have to reduce the speed of the machine. So this is, drives are not connected, left hand drive and right hand drive. The figure is shown is what, right hand drive. Same duplicate figure will be, drive will be present on the what, right hand. So these drives are not connected to the what, sleigh. It is connected to what, machine frame, and not movable, fixed. When the sleigh goes backside, back center, when the sleigh is at the back center, this Rapier tapes goes to the middle of the machine and comes to the what, side of the right hand side or left hand side. So for the sleigh the dual will be there. So you draw this first figure. I will be giving you 2 minutes. So this is what a first drive you have seen. You draw this first figure and we'll we'll take another next 2 minutes to draw the what? Second figure. So draw first this figure. Now take another 2 minutes for this figure now. Next drive of flexible drive we have seen. Draw the figure carefully and label the parts. In the exam, the question may ask explain various types of drives used in flexible Rapier wing for 8 marks. So you have to explain each and every drive you have to explain here. Hope you are drawn properly. Now this third type of flexible drive we will see, that is crank and rack operated. So crank and pinion. So rack and pinion is there. So this is what rack and this pinion. So how it works that we'll see. See this here first. So this is what main shaft and here is what wheel. So we can see here is the wheel and to the wheel we have attached a rack to the side of the wheel, not at the center of the wheel. Okay. This is what rack we are attached by the lever to the side of the wheel. So we can see here. Means when main shaft rotates, this lever will move clockwise and anti-clockwise. So see here, when this rotates, the rack will move one time upward and one time backward, one time upward and one time downward. So when this rack is moving one time upward and downward, the pinion here sixth shown, it moves one time clockwise and one time anti-clockwise, clockwise, anti-clockwise. So here we can see this is giving drive to this big wheel. Big wheel. We can see this big wheel. So this big wheel is moving one time. Big wheel is called as flywheel. The flywheel is moving one time clockwise and one time anti-clockwise. When the flywheel moves clockwise, the rapier, see a rapier head is there. The rapier goes in the housing. Here, see the housing is there. House of the rapier tape flexible, it goes inside. When it is moves clockwise. When this flywheel moves anti-clockwise, the tape gives this flywheel gives drive to the what? This tape. So here teeth are there on the big wheel. It is meshing with the what? Our tape. The tape goes as this moves anti-clockwise. The tape goes inside the shade up to the center of the machine. So this is what left right hand side drive. Same drive will be present on the what? Left hand side. Two drives are there, left hand drive and right hand drive. So this is what driving mechanism. So drive comes from the what? Main shaft. Then this eccentric will move one time clockwise and one time anti-clockwise. And the rack will move one time upward, one time downward, and then this pinion will move one time clockwise and anti-clockwise. So this flywheel, bigger flywheel, move one time clockwise and one time anti-clockwise. So when it is moving clockwise, the rapier tape comes inside the housing. So rapier is out of the shade. And when it moves anti-clockwise, the rapier goes to the center of the machine. So draw the figure of this rack and pinion type drive. So here we can see that the drive is very important because the motion is not simple harmonic. The motion is what? Eccentric drive to the rapiers. The velocity of rapier is not same while going inside the shade and while coming inside the shade. So and also we can see in earlier days we have used more number of moving parts, mechanical parts from the driving system. So more energy is required here, more force is required. So due to this what complication in drive is there in conventional drives, and more load is there on the what drive, the speed. So that's why the speed of machine is also reduced if such types of drives are there. So take few minutes to draw this drive system. So these were what some conventional drives we have seen. So every machine manufacturer is having its own drive. So whatever we have studied now, that is all what conventional drive systems of the flexible. In the next coming lecture, we will see what modern drives, how the modern drives are there. In the modern drives, less number of elements are there, mechanical parts are less. So driving setting is also easy. That is called as what? Stroke change, stroke setting of the rapier. Means what? When the width changes, the entry point of the rapier will change. So how to change that stroke, that also we'll see. So in the next coming lectures we'll see the stroke settings, and also we'll see how the modern rapier drives are there. So today we'll stop for this drive system lecture. Thank you.